Okay, so in the previous session we have seen arithmetic operators, all operations you have performed, right? Plus,
Yes,
minus, multiplication, division. And how about finding greater number program did you do?
yes.
Okay, that
Which
means we have seen relational operator. Like finding smaller number
yeah.
and finding if given two numbers are equal or not equal,
Yes, yesterday yes.
and finding if number is even or odd.
Even or odd, I didn't remember even odd is, I guess.
Okay. All right. So now we will see typecast. Okay. You know.
Okay.
So in this one, type test operators, there is, like the type of variable A contains string, type of variable B contains fraction value. Okay, and we need to compare these two values. Okay, whether the A is a string, okay, and then B is integer. Okay, then in that case it returns true or false. Okay, so let me help you with that. First, let me share my screen. Open up the compiler. Do you have my screen?
Yes.
Yes, yes.
Okay. Okay, so we have to create two variables, string variable and double variable. Okay.
Okay.
So here we create string variable name, okay, is equal to concept. Then double 5, okay, 3.147. Then we want to say if print a name is string, okay. Then we say print pi not equal to int, okay. Okay. So, oh, sorry,
Yes.
I have written it in a loop. Okay. See, here now we run this. See, it's returning true. Okay. All right.
Yes.
So there is a is and there is, we can also check is not also is there. Okay. So you can check here is not linked. Okay. So is and is not is there. Okay. So you can check it like that. Okay. And we can use as operator. Okay, let me send it to you in the chat. That's what we are seeing. So we are checking is and is not. Okay.
Yes.
So
Is
example is, whether the string name is string and pi value is not integer. Okay. So in that case, it returns, true or false. Okay, it's a Boolean value it returns. Then there is, as operator. So what is as operator basically? It is used, for typecasting, like to perform casting at runtime. Okay. If the cast is valid, otherwise it will throw an error. Okay. So now let's check it. So what is typecasting? So let's say, that we have dynamic variable, and you put a string in it, okay? And then you can convert that to, that value variable and put that value in a string. So, okay, let's check it. You will understand that. See, we have here dynamic variable first. So let's comment this part. And now we will create one dynamic variable. Here we will create value, val is equal to, and here we put one message in it. Okay. So now what we are going to do is, we are going to actually, typecast this value, okay, and put it in a string variable, okay, or name variable, okay. So what we do, we use as operator, okay. So in this one, we do here create string name, okay, and value as string. So it's a casting. This is called typecasting, and then we print name. Okay, you understand? So this is called typecasting. So let me send this program to you.
It is used with val only.
No, no, it can be used for any different variables. Okay, dynamic variable is such a variable. It can store anything, But if you want to put this value in this name one, see, this is string. Okay,
Okay.
but if you do this, like val string name is equal to val, but this has type dynamic, so it won't allow you to store that. So unless you convert it to string, okay. It's like
Okay.
two string. Okay, like PHP, there is a
Yes.
constant two string. Okay, so anything that is object.
Okay. Okay. Means a
But
conversion from
yeah,
integer
yeah,
to string and
yes, yes,
what?
yes. So this is though it is a string, but its type is dynamic, no? So
Okay.
this
Okay.
value variable is not just a string type. It can be we can actually store anything inside this. Now this is integer type. So it has varying type. So it's not like you cannot. So it's for in your understanding it's a string variable, but actually its type is dynamic. So that's why we convert it to string. Okay,
Okay.
you got it. So did I send you
Yes.
this in the chat?
Yes. It is shared.
I think I shared it to you.
Yes.
Okay. So now it's time to see the bitwise operator. Okay. So bitwise operation that we perform it on operands like bitwise AND is there, OR is there, XOR is there, bitwise NOT is there, left shift, right shift, and unsigned shift right is there. So you have to understand now what is this bitwise. Okay. So let me show you that what it is bitwise AND. Okay. So see here. Let me comment this part. Pay attention, please. So in this one, it's a integer a is equal to 5. Okay. And the binary value for this, is do you know what is the binary value for 5? 0, 0, 0, 0, and 0, 1, 0, 1. Okay. This is the binary value. Okay.
Yes.
And what is the binary value for 3? It's 0, 0, 0, 0, and 0, 0, 1, 1. Okay, I just provide a space between after each digit. Okay. What is bitwise AND? And we'll say bitwise AND. So it's where C, okay, equal to A and B. Now see here, look at the bits, okay. So when both are 1, okay, when both digits, like see, this is A and this is B, right? So check the last digit, last bit. So both are 1,
One.
okay, both are
Mm.
1. So the output will, see, the answer
One.
will be, 1.
One.
Okay, for and if both bits are 1, the answer is 1. Now here both, see, one is 0
Zero.
and the other one is 1. Okay, so the answer will be 0.
Zero.
This will be 0.
Zero.
This will be 0. So only the case when two bits are, 1,
One.
then the answer is 1 for the bitwise add. Okay,
Yes.
you understand? So
Yes.
what is the C then? This is the C, okay? This is C, this is A, this is B. Okay. So the C is 0, 0, 0, 0, 0, 0, 0, 1. So this is actually in decimal. This is number 1. This is number 3. So 5 and 3, it's a 1. Okay. So when you print C, you actually get the answer 1. See? And when you put here other number like 7, let's see, answer is 5. Okay, when you use 8, answer will be 0. You understand? So what happens at bit level? At bit level, so this is the binary value for 5. This is binary value 3. So what happens? Each bit will be checked. So here, see, here what happens? Last bit 1, last bit 1. Okay. So for A, last bit is 1. For B, last bit is 1. 1. When both are 1, then only the answer will be 1. This is the AND rule. Okay. What is the AND rule? For AND, both, if both are 1, then answer is 1. Okay. Okay. 1 means true. Okay. If both are true, then answer is
True, true,
1
true,
means
true,
true. So
false.
either one is, like 0 or 1 or both 0. Then in that case, the answer is, 0. It means false. Okay. So you can say here, if one of the bit is, okay, 0 means one of the bit is false. One or all. Okay. One or all. Okay. See, at least one is 0, then it's a 0. If all are 0, then also it is 0. Okay. Understand? You got it? So with the or, what
Yes.
happens here? With the or, what happens? Let me copy
One
this.
zero. Yes.
So this is for and. Okay. So let me
And
bitwise and.
and
Bitwise and. So you understand? So only thing you have to know that this is
yes.
binary value of 5. So you can find the binary value also. Okay. Like how? See, binary to decimal online. Okay.
Yes.
See here, binary to decimal is there, or you can do decimal to binary also. Okay. So you put here 5, you can do convert. Okay, it will convert it to binary number. So convert. Oh, sorry. I put it
Binary
decimal to
decimal.
binary. No? So here actually,
Binary.
Yeah, but here it's saying enter binary.
Enter binary number. Decimal number.
Okay, let me refresh this one.
Mm,
Decimal and binary.
But enter
Okay,
binary
now
number.
it is saying binary. Okay, see 101. Okay, so here is
Yes.
4 bits. Here is so generally the number is represented by 8 bits. Okay, here it is represented as 16. Okay, 16 bits. You got it? So binary
Yes.
number for 7, decimal number is 7. We convert it to binary. We get C 4 times 0. Okay, 0 0 0 0, then 0 1 1 1. Okay, so you get a number and put it in here. Okay, so let's do that. This is bitwise and now let's do it for
Bitwise
bitwise
or
or. Okay, or is exactly opposite.
0 0 0 1 0 1 0 1.
So either bit is one, no? Either bit is
Yes.
one. At least one bit is one. Okay.
Yes.
The answer is one. So let's say we want to do or here. Okay. So
Yes.
see here two we have two ones. So answer will be one.
Double
Here
operator.
we have a single one. That is okay. All right.
One.
Somehow we need at least one bit as one. Okay. Minimum bit one is required here. Okay. So 1 0 again this is one. Okay. Here both are zero. So no doubt here all bits will be zero. So this is, like what is this binary number? I don't know. So I will copy this. I go to decimal to binary. I do here binary
2 decimal.
and decimal. Okay. So then I copy here binary and I convert it to
Convert.
decimal. So I think we need to remove these spaces. Okay.
Yes.
You got it? Here we have 7 decimal. All right. So here what will be the answer?
7.
7. Okay. So if we do print C, we will get answer 7. See, you got it? So I'll send this program to you. Can you do this program now quickly?
Okay.
Okay, Nain, I think we should see one more point, okay? We have seen OR. We'll see XOR, okay?
Yes.
Okay, so Nilesh, you pay attention. So what is XOR? So let me comment this part first. Nilesh, are you following?
Yes, yes, yes.
I think 2 times it is copied. This is XOR. XOR, what it does basically. So this is XOR. So what is XOR here is basically when both are same bits. Okay, here let me correct this. Bitwise or if at least minimum bit value should be 1, at least 1. Okay, so in that case the answer is 1. If all bits are 0, okay, if all
Mm.
bits are 0 false, then the answer is false. Okay, and otherwise it's true.
Bit zero,
Otherwise true.
then four,
Okay,
and then
so
answer
this
should
is for
be.
all. And for X or C, if both bits are same, if both
Mm.
bits are same, meaning it could be 1,
Zero.
okay, 1 or
Of mm,
0, 0.
zero.
Okay, in that case the answer result is yes, 0 means false. Okay, so do you understand from this that both are same, all bits are same? Okay, both or all. It's not about just 2 bits. Okay, there could be 3. Otherwise, we can say it's true. You got it? So
Yes.
see here we have 1, 1. Both are same, no? So value
One.
will be 0.
Yes.
Here
Okay.
it's a different. So we have 1.
One. One.
Here
One.
1.
One.
Both
One.
are same,
Zero.
so
Zero.
0.
Zero.
Okay. So what is this? This is decimal place value is 6. Okay, see, you got the 6 now. You understand? This is bitwise XOR.
Yes.
Okay. All right. So I will send this to you now. And after this, we have to see not. Okay. So what is not basically? It inverts the bits. Okay. So it's like, we have integer value 5. Okay. Integer a is 5. And, we have variable inversion IA. And not means tilde. Okay. This will like, it's a ones complement. Okay. One's complement meaning, okay, variable A is already used, so we will comment these parts. Now in this one, when we bring A, so I, what should be the output? Let's check it. Okay, say semicolon is expected. Okay, see, okay, it's a very high value. Okay, now what is this value? How did we get this value? Okay, so basically, let's understand this. Okay, we have value 5. So binary value for this is 5 is 0, 0, 0, 0, 0, 1, 0, 1, isn't it? So when you say not means you invert all bits, like you make this one as 1, this one as, so 0 becomes 1, 1 becomes 0. You understand? Now, this bit is a integer, so now what is this value in decimal? Okay, so let's remove the spaces. So let's convert to decimal. It's a 250. Okay. So let's say it's a 16 bit. Okay. This is not 8 bit. Let's say this is 16 bit. See, it is 65,530. So let's say it's uh, you know, this is 16 bit. So 16 plus 16, 32 bits. Okay. You got it?
Yes.
Yes.
You got it? 65. Now you convert this. See what value you get here?
42.
4294967290. Understand?
Yes.
Now look at here. See, same value. So what does it mean? This is 32 bits. Okay, this number is a 32 bits. Okay, so but we don't have, okay, here. So I will put dot here. Okay, we have uh like total 32 bits here. Okay, I don't have space for write all these ones, so you understand. Okay, you got it. You understand this? Not means what it does. It inverts all the zeros to one, one to zero. Okay, inverts all bits.
Okay.
Understood? And now left
Yes.
shift, and now let's understand left shift and right shift.
Okay.
So left shift and right shift, what does it do? So let me first do comment here. Here we say integer a is equal to 4. Okay. What is right shift? So let me do a equal to or b equal to a right shift 1. Okay. So what happens basically? The binary value for 4 is 0 0 0 0 is I think 1 0 0. Okay. You understand? You understand?
Yes.
Yes. Or
You got it? So what we have to do, we have to shift one bit towards right. Okay, we have to make this one is integer. So right shift one bit. So that means we have to remove this bit. Okay, you understand?
Mhm.
So I think one more bit is required here. Okay. So when you are sitting, let's say there's eight people are sitting in here. Okay. So, we have to write shift
0.
means one student, one person, it will move out, you know. Shift means
Mm.
it is gone now. Okay. Shift means that person doesn't have a space to sit. Okay. That means it's out from one end. Okay. Now we need one more bit towards left. Okay. So we add zero towards left. Okay. So this number is, become like this: 0 0 0 0 0 1 0. We got it?
Yes. Good.
So when you print, what will be the output?
2.
Hmm?
2.
When you print, what will be the output? When we print V,
B. 2.
it will be 2. Let's check. See, if it was 8,
Then it will be 4. I depend 4. Mm.
okay. So when it's 8, what will be binary value for 8? It's a 1 0
4.
0. So what
4.
happens? One bit goes out. For right shift. Right shift means one bit goes out and new bit comes in. So when you add new bit, no, you add it towards left when you do right shift. Okay. So this is 4. Okay. You got it? So actually what is happening, say 8 becomes 4. 4 becomes 2. Actually, it's making half. See, if it's a 16,
Mm,
it becomes 8. It's doing half. It's like
s-
dividing it by 2. If it's 32, divide by 2,
16.
16. So it's doing division actually. When you do right shift, no, it's doing division by 2. Okay, you got it? And it's a vice
Mm,
versa. You do left shift. What happens?
uh,
One bit from the left, it is, gone. It is removed, and one new bit is
double
inserted towards right. So
64.
it's doing double. Okay. When any new bit 0 is added towards right, it's double. When any new bit
Mm,
is added towards left, it is half.
yes.
You got it? So you want to do multiply by 2. You do left shift 1. You want to divide it by 2. You do right shift. You understand? So this is left shift and right shift. I hope you understand. So I'll be giving you these programs. You please do it now. And please share your screen, okay? I'll be sharing this to you. Oh, it's too many codes, too many lines of code here. I cannot add it. So let me just put first up to all, and then bitwise all to the end of the. Okay, I have sent it to you. Okay, please check it. So the last program, it's a complete program. Okay, you understand what
Yes.
is this left
Yes.
shift, right shift? In the interview, in the interview, actually, the interviewer asks you like, how can you, do multiplication, multiply the number by 2 without doing, you know, multiplication sign, without using multiplication sign. Okay, so you might, you used to do it like this. So you say like a is equal to 32. I want to double. So what you will do, how you will write integer b is equal to a into 2. But interval says we don't have to use these multiplications. Okay, in that case, you don't have any options to do there. Other ways you don't know it. So basically, the other way is, you want to double this. No, you use right, left shift. The value will be doubled.
Yes.
Same way for interviewer says, I want you to, divide the number by 2, but not to use this divide sign. In that case, you can use right shift. Okay. So right shift 1, not 2. Okay. So if you use 2 no, then it will be first 16, then it will be 8. Okay. See, here I will use number 8. So if I do right shift 2, that means first it becomes 16, then 32. See, because 2 times you are doubling the value. Okay. First time you double, it becomes 16. Another time, and second time you double, 16 becomes 32. You got it?
Yes.
Okay. All right then. So how about you do these programs, okay? Like binary operators and all. Okay. Can you do it? Can you please share your screen? If you have any doubts in this program, okay? You can feel free to ask me. Do you have any doubts, Nayan, Nilesh?
No,
No.
no.
Okay, then please share your screen. I'll stop sharing screen. Nayan or Nilesh, you start sharing your screen.
Okay. Mm, you need to request the host to allow multiple sharing. You need to turn on the sharing.
Teacher XOR झाला int is equal to 5 then val tilde.
You're allowed to share the screen now.
Okay.